let's take a look at some more angles and see how we can generate more interesting identities between arc measures and angle measures. So imagine that I have a tangent line that intersects with a secant line. So remember, a secant line is just a line that actually crosses the circle at 2 points. Well, then we actually produce an angle here. I'm calling it angle 1. And we can ask, well, how do we find that angle? Well, in some sense, if you think about it, it's going to somehow relate to this arc, but also it's going to relate to this arc as well. And how does it relate? Well, it turns out that the measure of angle 1 equals 1/2 the measure of arc AD minus the measure of arc BD. So in some sense, it's not that we're taking an average, but we're sort of counting this as sort of negative ground. We've gone out this way, and now we're going to come back, and so to take into account that, we now subtract off by that amount, and then we divide by 2. So it's a similar kind of identity. And in fact, this identity holds even if we don't have a secant line. For example, imagine the secant line were actually a tangent line. Well, then, in fact, the exact same identity holds. So if I have two tangent lines that intersect somewhere here at F, and I'm taking a look at this angle here, 2, angle 2, then in fact I can compute angle 2 how? By taking 1/2 the measure of this outer arc and subtracting off the measure of the inner arc. In fact, this holds even if both lines were secant lines. For example, suppose I have these two secant lines that intersect at L, making an angle that I'm going to call 3. You can actually compute the measure of angle 3 by the exact same principle. We take 1/2 the measure of this outer arc minus the measure of the inner arc. So in fact, it doesn't make a difference whether we have two secant lines, whether we have two tangent lines, or we have both a secant and a tangent line. The exact same formula holds. We take 1/2 the measure of the outer arc minus the measure of the inner arc. Let's take a look at an example together. So for example here, our mission is to find the value of x. So find the measure of that angle. How do I do that? Well, I know the outer arc is 120. I know the inner arc is 50. And so x is going to equal 1/2 the measure of the outer arc, 120, minus the measure of the inner arc, which is 50. So what does that equal? Well, that equals 1/2 of 70, which equals 35. And so this angle right here is 35 degrees. So you can see how easy it is to actually use this formula once you realize exactly its significance. Let's try one last example. See if I can stump us. So we're given this picture here. We're told that these two lines are tangent. So one line is tangent to the circle at P. One line is tangent to the circle at R. That's given to us. We're told that this inner arc right here is 140. And our mission is to find out what this angle Q is. Well, we know for sure that y is going to equal 1/2 this outer arc, which I guess equals the measure of the arc RSP, minus the inner arc, which is 140. The question is, we don't know this arc. Or do we? Well, let's see. I know that, in fact, these two lines are tangent. So, in fact, what about the measure of this arc together with the measure of this arc? Well, those two arcs together fill up the entire circle. So we know if we go once around the circle, we have 360 degrees. We know 140 of them are here. So if we take 360 and subtract 140, then we know exactly what the measure of this arc is. It has to be 220. Isn't that neat? So since we have two tangent lines, there's no extra sort of arc left over. All the arc is here, so this arc plus that arc has to equal once around, which is 360. Well, now once I've got that, I can plug that right into here, and so I see 220 minus 140, which gives me 80, and you take half of 80, we get 40, and so therefore the measure of angle y is 40 degrees. So that's really cool. You can see how we can extend the notion of angles by looking at various things, including secant lines and tangent lines, and we can actually find those angles if we know the measures of the corresponding arcs.